Hello everyone, welcome back to our explainable AI class. Today we are going to explore something that actually let us see inside of Mind AI. So up to now we have studied how AI models learn and make predictions, but have you ever wondered how do we know what exactly the model focused when it made the decision? For example, when a CNN model says this is a cat, how do we know what part of the image made it say that? Was it the ears, the whiskers, or maybe even the background? So that's where today the topic comes in, and we will be learning about the three amazing techniques: GradCam, gradient weighted class activation mapping, and then second one activation maps, then third one sensitive analysis. So together these techniques help us see, understand and trust our AI system. We go for next slide. So the first one, let's begin with the GradCam. So GradCam, one of the most popular visualization tools for deep learning models. So GradCam stands for Gradient Weighted Class Activation Mapping. So it is a basically visual explanation technique for convolutional neural network, which means CNNs. So remember the CNNs, they are the models used for image classifications like recognizing a faces, animals or a vehicle, etc. So now imagine this, you feed an image of a cat into a CNN. So the model predicts cat, but the GradCam helps us answer why. It shows the which regions of that image were important in making that prediction. So if you have a cat sitting on a sofa, the GradCam might highlight the cat's ears and eyes in the bright red. So that's the mean the model look at the part to decide it is a cat. So let's visualize it. Imagine we give a model of a dog image. Okay, the output is a heat map. The colorful overlay that shows the where the model looked. So in that heat map, the red areas mean high importance. The model paid a lot of attention there. Blue areas mean low importance. So the model did not care much about the pixel. Okay, so red means the high importance, blue means the low importance. So in our dog image, the GradCam heat map will glow red around the dog faces or ears, so showing the decision focus. So this is why GradCam is important. So GradCam how can work? Okay, so the GradCam works for any CNN architecture wherever it's a ResNet and VGG or mobile net. So it's a class discriminative, meaning it show the attention specific to the predicted class, and most importantly it's a human understandable. We can visually the reasoning. So this is about the application in medical imaging. So GradCam help the doctors visualize which region of an X-ray or MRI the AA found suspicious. So in autonomous vehicle, it shows what the part of the road the car's vision system focused on. So like the pedestrians or lanes or signals. So this is the working procedure of GradCam step by step. Okay, under the good how the GradCam actually work. We first take the gradient of the output, say the score of the cat class with respect to the feature maps of the last convolutional layer. So this gradient tells us how important each feature map was for the class. So then we take the weighted average of this map using those gradients as weight. So finally we pass this through ReLU, the function and overlay it the original image. So the formula GradCam equal to ReLU sigma AK small ak and capital AK, where small ak activation map from the convolutional layer and capital AK gradient based importance weightance for the map. Okay, so the real you ensure we only the highlight the positive influences, the areas that increase the class confidence. The next slide, this is an example, dog image. The advantages. Say the advantages of GradCam, it is works for CNN architecture and the human understandable heat map. It's widely used in the medical imaging autonomous. So previously I was told that. Now let's move to the activation map. So while GradCam shows the where the model looked and the activation map show what's the model learned. So each convolutional layer in CNN, the output several activation map. These are the basically the responses of the neurons to the feature image. So let us understand visually. So in early layers, the neurons learn to detect edges and corners, simple patterns. In the middle layer, they detect the high level objects like they detect the textures, patterns and shapes like fur or wheels. In the deeper layer, they detect the high level objects like faces or animals or cars. For example, in a cat image, the layer 1 might activate fur edges, and then the layer 3 might respond to the whisker patterns, and layer 5 might detect the cat face structure. So the activation map help us to see the learning process from the simple to complex understanding. So these are the three layers, early layer, middle layer and deep layer. So why activation maps are useful? So these maps are not just for curiosity. They have a practical uses. They help us understand how the features evolve across the layers. So we can detect overfitting or bias. If the certain irrelevant regions are highly activated and when combined with the GradCam, we get a complete picture. So both were under what the model focused on. So you have to remember this line. GradCam shows where the model looked, activation show what it learned. So now we move to sensitive analysis. So which is about the testing the stability of our model. So think of it like this. If you slightly change the input, does the model output change drastically or remain stable? So imagine the model predict whether the X-ray is a normal or abnormal. If we are changing one pixel makes the prediction flip, that's the problem. So it means the model is too sensitive and it not reliable. So sensitive analysis help us to find out the how robust or fragile the model is. So there are the two main types of sensitive analysis. First one local sensitive, second one global sensitive. So local sensitive mean the small or local changes in input. For example, adding a tiny bit of noise or slightly changing the brightness. So we check whether the prediction remains the smooth or jumps around. Then global sensitivity. It is a larger or more noticeable changes. Maybe removing a big portion of an image or altering a several features. This test is a model's robustness across a wide range. So for automatic vehicle, which one is important? The model should not get the confused just because the lightly changes or there is shadow on the road, right? Which means the global sensitive because the safety that depends on the stability under all the conditions. Let's connect these ideas into the real life AA system. First one, healthcare. So GradCam highlight the tumor areas helping the doctors understand AA decisions. So sensitive analysis ensure the model is not unstable due to noise or image quality. The second one is automatic vehicles. Activation maps show where the car is detecting the lands or obstacles. Sensitive analysis check whether the sudden lighting or changes affect deductions. And then finance department. So when predicting the credit score, the sensitivity analysis ensure the fairness. Small changes in non-important factors like age or region should not flip the decisions. Okay. So in every industry, explainability improve the trust and safety. So if you would like to try this technique yourself, here are the some powerful tools are there. So first one is tensor board, great for visualizing activations and embeddings. Then second one is Google Looking. So for feature visualization, exploring what neurons respond to. Then third one is touch vision or Captum. It helps create the saliency map and gradcam output easily. Fourth one, deep dream. So this one is fun, but it exaggregates the features the neurons love creating dream like artistic image are full of dogs and eyes. So this is the summarize of how all the pieces fit together. So concept, goal, output type and then example. So see how it flows. We move from teaching AI to explain itself to actually seeing what it sees and then exploring what it learned deep inside. To wrap up, where do we see this concept in practice in the healthcare, highlighting the regions and organs, automatic vehicle, visualizing the focus on pedestrians or road sign, NLP models, using attention visualization to see which words influence meaning, and then security, visualizing the anomaly detections to catch the fraud or intrusions. So whether it is a doctor or driverless car or a bank system, visualization techniques like a GradCam or activation maps, a sensitive analysis to make a AI decision process and a transparent and trustworthy. So alright everyone, let's conclude our session. So what did we learn today? GradCam tell us the where the model looked and then activation maps tell us what it learned. Sensitive analysis tell us how stable it. So together they form the foundation of explainable AI visualization. So in the next few years, explainability will not just be an option. It will be a requirement. So because as a AI becomes more part of healthcare, finance and safety system. So we must able to say not just what AI predicted, but also why it did so. So next time you see an AI model giving a prediction. Okay. Thank you.